With that being said, what I want to talk about today is to getting into the hyperbolas. And hyperbolas are the last of the conics that we're going to look at. They have the most stuff involved in them. From earlier in the day today, people have kind of picked up on them rather quickly because the same things that you have been working with, whether it was A, B's, and C's, they still mean the same thing. Whereas your A value is still going to be the distance from your center to your, to your vertex. Your B value is still going to be your center to your covertex. Your C value is still going to be the center to your focus. Those three values don't change. What changes now is how it's set up. So within hyperbolas, you have the two generic formulas, and we're going to do non-shifted today.
Just the non-shifted?
We're going to do non-shifted today. We'll do the shifted stuff next week. Like I was saying with some other people throughout the day today, my goal for working through the hyperbola section, since there is quite a bit going on, is that we're going to do the non-shifted stuff today. We'll shift it on Tuesday, maybe start writing some of the equation. After that, on Wednesday, we'll finish with the writing equations. On Thursday, then, I'm going to give you guys probably 3 questions on it. And then that'll only be like 20 minutes worth of work. After that, we will start Chapter 6. The first section that is in Chapter 6 for our next unit on polynomials is stuff you've already done. It's working with exponent rules. It's a brief review on that. Yes, ma'am? Because Common Core says we're not supposed to.
I like it this way.
It
makes it seem random.
The book is from 12 years ago. This stuff wasn't around. So it is. But then again, numbers don't change. It's just a sequence of things. And like I've said before, it's not my decision on how things are going. It's people above me.
It's Obama's.
It's not just it. It's a lot of stuff. Okay. Yes. Yeah, very small amount. Okay. So let's get started on this. What I want you guys to look at here when you're seeing the two different formulas for the generic forms of the hyperbolas is what changes. Subtraction has happened now as opposed to the addition. That's the main difference between that and an ellipse. But what changes?
Where how last time it was like the y squared moves, like the a squared moves, but now it's the y squared.
Correct. What happens now, the difference is the x squared and the y squared are what moves. The a squared and the b squared don't. Correct. These no longer, the a squared and the b squared no longer relate to biggest number. It just is the first number is a squared, the second number is b squared. That's what that means. What happens now is what comes first, x squared or y squared. That's what shows you the directionality of the conic. So if the x squared comes first, it's going to open left and right. If the y squared comes first, it opens up and down. That's what that shows. Okay? The a squared and the b squared is just first number in the fraction, second number in the fraction. That's all they have in common anymore. That's it. Okay? So it's a little bit different than the ellipse. The other stuff that happens is the same. Your a value, it will still be center to vertex. Your b value is going to be center to, it's not technically called a covertex, but I call it that. I forgot what it's really called. And then C is your center to focus. Next week we will add in the h's and the k's. So it'll wind up being, x minus h minus squared, y minus k minus squared. The h and k will still become your center. Today, it's just after the origin. Yes, ma'am?
So like A doesn't have to be bigger?
Correct. The only thing that shows you, it's just, remember the first number is a, or a squared, excuse me. The second number is your b squared. To show what direction things are going, up and down or left and right, it's x squared first or y squared first. That's how you know which way it's going. Okay. Again, I will make sure that you guys have that formula in your calculator, or I'll have it on a sheet. It shows the direction in that app of which comes first, so you know what direction things are moving. Okay. I think the easiest thing to do with this is to jump right in and show you an example of a problem and go from there.
Yeah. How do we know if it's up or down or left?
What comes first? x squared, it goes left and right.
No, like, if for the y squared minus x squared, how do we know if it's up or down?
If the x squared value comes first, it's left and right. If the y squared value comes first, it goes up and down.
So,
But
you said a squared has no intention
Positive
bigger
or
one.
negative? Up like a couple or down like a couple?
It's not like that.
You said,
That's what I'm asking, like, if it's positive, does it go up, and if it's negative, it goes down?
Hyperbolas have two curves.
So it doesn't-
Oh.
Hyperbolas have two curves. I'm sorry.
Yeah.
Hyperbolas have two curves. Okay, it's basically two parabolas.
Hyperbolas are curvy, if they're hyper.
Let me show you an example.
Please don't make it, please don't make that.
Okay? We'll start with this. X squared over 25 minus y squared over 49 is 1. Your center is at the origin. What comes first? X squared or y squared?
X squared.
X squared. So this means this is going to be a left.
What's so funny?
Wait, this means it's going to be a left and right hyperbola. So just like we did in the past, I'm going to sketch it like that so I don't screw up
Why
later.
does it look like two noses touching?
It doesn't.
And I'm going to do the same thing. A squared is 25. B squared is 49. And here's what's new. C squared. In all of our curves, the vertex always opened up to the focus, whether it was a regular parabola or an ellipse. Now, since our hyperbola opens left and right, and my center is in the middle here, that means my focus has to be further away than the vertex. Okay? So now the c squared is going to be found by a squared plus b squared.
So it's like the Pythagorean theorem now?
Kind of.
Because it's the same formula.
I know. Okay? So our c squared terms can be found by adding them together. Now, one thing that it's going to be easy to remember of which one you're going to use, in a hyperbola, the generic formula is a subtraction symbol. That means that its c squared is by a plus. In the ellipse, it was a plus, and the c squared had a minus. Remember that?
Yeah.
It's just the opposite through there. It'll be easy to keep these things straight because you're only looking at hyperbolas right now. So in this case, your c squared value gets you what? 64? 74, excuse me. Okay. A is plus or minus 5. B is plus or minus 7. And C will be plus or minus root 74. I'm pretty sure I can't simplify that because it goes, yeah, 37, yeah, you're done. Here's how you plot these. It's exciting. We start at the origin. That's my center. My h and k is 0, 0. My vertex is my a value, my distance from the center to the vertex. A is plus or minus 5. I know from earlier that I sketch it, it's got to go left and right. So I'm going to go left and right 5.
Oh, it seems so nice.
My co-vertex goes up and down then.
Yeah.
If it was like the other equation would be the opposite.
Okay? Here's where it gets weird. When you're working with a hyperbola, what you want to do to be able to show how your curve looks, you create what's called a rectangular box around these points. Let me show you. You do this. Make a dotted rectangle around the outer edges of those points.
Oh, here we go.
Okay? This rectangle allows you to get diagonals. Your diagonals within a hyperbola graph are what they call slant asymptotes.
Hey. That's a cool term. Asymptotes.
Asymptote. An asymptote is something that you're always approaching, but you're never going to touch. I'm not touching you. I'm not touching you. I'm not touching you. I'm not touching you. I'm not touching you.
How do you spell that word?
It is obnoxious. It's an asymptote. You smack them. Right. Okay?
Moto.
Asymptote? I don't know. I can't.
It's got a P.
I'm sure there's. I don't know.
It has.
I have a degree in math.
Oh, you messed up. The M and the
It's okay.
Y are switched.
Whatever. I think you're right. I
Oh,
think it's asymptote.
No,
Wait,
that's what it
it's
says
ma?
right here.
Oh, okay.
I thought it was.
So right now I have plotted on my graph, my vertex is somewhat what?
Wait, so what is the asymptote?
It's a diagonal. It's just the asymptote right. Okay. I'll tell you in a minute here what the asymptote is going to allow us to do. Okay. These asymptotes are just drawn in from going the diagonals of this rectangular box that you create. It works every time. It does the same thing. The diagonals are going to show you how fat or how skinny your parabolas or your hyperbola is going to wind up being. Okay? The steeper the slopes, the larger of the asymptote. The skinnier the slope, the quicker of the asymptote. Okay? So in this case, my focus value is root 74. I still need to plot that. My vertex is going to look at that. Root 74 is more than 64, but less than 81, so it's what, 8-ish?
A.
8-ish.
8.5.
So if this was 5, 6, 7, 8, 9, so it's somewhere in here. So I plotted my foci. Notice my vertex will look at my focus. God bless you.
Bless you.
And then the last thing I have to do is draw in my curve. Drawing in the curves of these things is the same every time. We know this has to move left and right, so I hug the asymptote, I go through the vertex, and I hug the other asymptote. That's it. So,
How can you?
hug your asymptote.
Like, that's hard to draw, right? Anybody else having trouble? 'Cause I'm like, I can't seem to
It's
do
the
it.
first time you've ever drawn one.
I'm
Don't
not
be
having
surprised if
trouble
it
at all.
takes a couple to get it right. And that's all there is to it. All that's left now is just the label. Our vertex.
See, now it looks like 2 notes of touching.
Oh, it does look like. Hey, that looks nothing like 2.
This is fun.
And then lastly, just labeling out your values, okay? The vertex is where the curve is going to go through. That co-vertex is that top and the bottom in this case. It's not technically called a co-vertex. I always forget what it's called.
How does the focus help us on this one?
Remember, the focus, the further away the focus winds up being, the larger the curve is.
Yeah, but we didn't use the focus on plotting them.
We did not, but remember, your vertex always looks at the focus.
So that's how you tell the difference between.
Yeah.
If your
It's
vertex,
kind of where it tells
if
you
your
where it's
foci
looking.
is bigger than your A and B, then you know.
Yes,
it's
sir.
curved.
One last thing that I'm going to ask you to do today is to find the slope of your asymptote.
Oh.
Now, this is very easy to do. Slope is what over what? Rise over what?
Why is it supposed to be?
That's slope-intercept form. It's not slope.
Oh, okay.
Especially
I don't know slope is.
rise over.
I go up. We went up 7, right 5. So your slope is 7 over 5. But notice you also can go down 7, right 5. So it's plus or minus 7 fifths.
7/5 x plus b.
Slope is
Rise over run.
rise over run.
B is 0.
Now, unless it's going up or down. It's just, what I'm doing here is pay no attention to what, this could be a vertex, this could be a co-vertex, this could be a vertex. I'm just, in this case, yes. All I'm doing is remember it's rise over run. Next week when we graph these out that are non-shifted, I'm going to ask you to write the equation of the asymptotes. Okay? Yeah, that'll be the slope-intercept formula.
Okay, cool.
All right. One of the reasons why I'm trying to get you guys into working with these asymptotes is we don't use them a ton in Algebra 2, but you will use them more in pre-calc. So I'm trying to get you guys practice to at least know what they are and how they work, okay? One of the other things that you'll do next year, as opposed to being just left and right or up and down,
They'll be turned.
they'll be turned like this as well.
Oh, that's easy.
So you'll have stuff like that as well next year. So I'm understanding, it's really not that, as long as you understand the vocabulary of what things look like, it's not that bad. Yes, ma'am.
How do you guys recommend if they're like up and down?
We do the same thing. I'll show you. I have an example there coming up, okay? Because if you're not worried about the curve itself, you're looking at the aspects. So even if this was twisted to this one, you're pushing this way, it still works the same way. Does that make sense? It's a great question. All right, let's do another one.
Yeah, actually. My dad's still outside. Wait, is it because that
Let's try this one. We have 4y squared minus 36x squared equals 144.
What's a circle?
But is it a circle?
What do we have to do? You divide it by 144.
Oh, yeah.
It's not going to be a circle because there's a subtraction symbol in between. So your first step in this case, like we would before, divide everything by 144.
What's 144 divided by 4?
36. Now, what comes first, y squared or x squared?
Y squared.
So will this be up and down or left and right? Up and down. So make a little sketch that you know so you don't screw up anything. I view that nicely.
Does that look like Jones's texture?
Okay. What's your a squared value?
36.
Good. So what's c squared going to be?
36.
Which is?
42 root 10.
We'll throw something at you.
It's not?
Just messing with you. It's making you think twice.
Plus or minus?
Oh.
Okay. Clay, I had to.
Oh, okay, you scared me.
So what's your a value?
6.
Plus or minus 6. To see how we're doing the same basic back work that we did last time, we're doing all of that first before you try to plot anything because it's easier. And we wind up with 2 root 10. Are we okay with that? Okay. Now, our center today, again, is still at the origin. So we just go ahead and start plotting that. A. A is my distance from the center to the vertex. So does A go up, or does A up and down, or left and right? It goes up and down.
Because it's A.
Because we know it's got to go up and down now because it's telling me that earlier that y squared was first, so I know it's got to be in that direction. So A goes up 6 and down 6.
It's not in the wheels.
Are we okay with that? That co-vertex goes left and right 2.
Yeah.
So in the previous problem, it was vice versa, right?
Correct, because we did that work up front where we noticed that the x squared term came first. That's why we knew it was going to go left and right. That's the whole idea of getting it in that generic form before you do anything else, so that way you don't make a dumb mistake. Okay? Yes, ma'am.
Would the focus be less than 6?
No. What's the square root of 40? Isn't it bigger than the square root of 36? Isn't that more than 36? So before I worry about my focus or anything like that, I'm going to draw my rectangle. Very
I
good.
already did that. It looks great.
Then what am I going to do?
Draw the
Draw your asymptotes.
sideways, Lincoln.
Lincoln.
Crazy kid.
Oh my gosh.
Hey, if you draw it the wrong way, all you have to do is just cut your paper and retape it sideways, it'll be fine.
Wait, can we do that?
No, I'm joking.
Oh.
That's okay.
Yes.
Are you seriously joking or joking?
Yes.
It's easy.
Now, so, hey, let me ask you this question. Is the square root of 40 greater than the square root of 36 or less than the square root of 36?
Greater.
It is greater.
It is greater. So it's going to be more than 6. Do you agree? Witchcraft. It's witchcraft. It's
Just
crazy.
by a tad.
It's just like it's raining.
6.3.
Smidge. We call that a smidge.
Schminch.
A smidge.
I got you.
It's about ish. And then now again, we know that it's got to be opening up and down. We draw it. Hug your asymptote, go through the vertex, and hug the asymptote.
This always ends up looking like a basketball game.
Kind of, yeah.
That's how basketball.
So you better be learning your asymptote from a hole in the ground here.
What'd you just say?
Know your asymptote from a hole in the ground.
I
I
get
get it.
I am 100% on understanding of it. I don't get it. I'm not even pulling no
Say it one more time.
Pull my finger, I have another asymptote question joke for you.
Clay was like, okay.
I thought he was going to make a joke, but I still don't get it. Oh my god.
Anywho, what's the last thing I have to do then?
Just
Label everything.
Label that out to find my slope. Thank you. So my slopes. Now, Lydia, this is where you're asking what happens when you're looking at your slopes here. Since I'm still doing rise and run, I went up 6 and right 2. So my slope would be 6 over 2, otherwise known as.
Plus or minus 6 over 2.
Does that make sense? It doesn't matter where your curves land at points. You're just walking through the line. Okay?
All right.
Great question.
Probably have to do this backwards, don't you?
We will.
Oh yeah. That's all I
We
know.
will.
Let it hit you. I was really like this where's my mouth shut. Get off my. So weird. He doesn't.
Let's see how we did, just because I want to do some homework.
All right, let's do that.
Question happened now. I'm trying to remember that.
If the transit property means
That's a big ass.
That doesn't mean I don't feel
I need M, so.
That's all like everyone gets like
I'll stretch it.
she's judging me.
Did you get those for your A, B's, and C's? Which one came first, X squared or Y squared? Y squared. What direction is this gotta go? Up and down. Up and down, good.
They drew in the wrong direction. She finds it
I'm
funny.
having fun learning math.
Don't BS. No, you're not having any fun.
I actually asked for
I'm just-
right.
He said, ass, put toe.
I still think, wait, what?
Wait, what did he
So many
say?
jokes covered. I didn't even think I got so
Ass,
too.
toe,
I
as a
read
potato.
Why can't we just switch the X to the Y?
He said, ass, put toe.
5 root 3. If I'm going 5 root 3, that's more than
8 something.
8 something.
8.6. Shut your face.
Come on, guys.
Right where you live. All you remember, I don't know.
All right. I do want to talk about how you find the slope of this line.
I know. I figured it out.
Okay? I want to talk about how you find the slope of this line when you've got a radical for your change in x.
Times root 3, times root 3 at both.
We know that your rise over run in this case, you went up 10, you went right 5 root 3. So your slope is going to be 10 over 5 root 3. Right off the bat, you know it's 2 over root 3, otherwise known as
2 or 3.
3 over 3.
Nailed it. I win.
I
That
did
is
it all
one of the
around.
more obscene slopes that you'd have to calculate because it's very difficult to walk to root 3 and then over 3, but it's still writing the equation out. Now, do you guys also agree, since we are centered at the origin, our slopes are just going to be plus minus?
Yeah.
You're shaking your head no.
Me?
Yes.
I'm still looking at the,
Rationalizing?
yeah. Did you just like, yeah.
I multiply top and bottom by root 3. And that's how I got that.
Okay.
Okay. What I'm saying here is if I go the other direction, I have to go down 10 and then to the right to root 3, or to the right 5 root 3. I get the same result just with the negative sign. The last thing I have to plot in there is my asymptote, or my focus.
Oh, yeah.
My focus value is got to go vertical again. So it's what?
13.2.
13-ish?
Yep, 13.2.
About
10, 11,
13.28756.
Just about.
And then once again, hug your asymptote, go for the vertex, hug your asymptote.
This was a one.
Wait, so the parabola goes on forever, but never ever touches the asymptote?
Correct. Correct.
Wait,
Yeah, that's
hold on. What
sad.
happens if like Earth? Isn't our point that we live on Earth? It doesn't round. Wouldn't eventually go all the way around and make a really big ellipse?
It's more spherical in nature, but yes.
Okay.
Okay. We use some problems to try. This is section 10.5. It's on page 619. I'd like you to do those 6 problems. They're straight graphs. They're not extraordinarily difficult. Please, I know I didn't do this in this last problem. I didn't list out all of my ordered pairs. Please make sure you list out your ordered pairs and also list out your slopes. Get in the habit of writing those slopes out because next week when we do the shift, when we write our slopes, it's not going to be centered at the origin. We're going to have to write the equation of the line that has the slopes.
Then it's x plus b.
Correct. So, and we'll walk through that. We'll do some point slope form with that. So there's a bunch of little steps there. Okay.
I gotta take my big shit from
wanna
Hey guys, do you want to do homework? Want to do homework?
No. Is it?